Hey dudes, we're on the last chunk, 5/8 tangents and normals. It's out of 16A. And if you're a physics nerd, you're probably experienced with the normals. A normal force is what pushes back on you, equal and opposite reaction. So if you have a box on a table and it's pushing down with a certain force, let's say 100 newtons, 10 kilograms. If you're not force inclined, the table has to push back with the same force, and we call that a normal force. It's perpendicular to the surface in question, so the normal force will be equal and opposite. Now, this equal and opposite isn't the part that you need to know. It's this perpendicular to the surface that you need to know. And so this is called the normal force, right? When you're sitting in your chair, you're pushing down on the chair. The chair's got to push back up at you, or you collapse and fall over, right? If the table doesn't support the weight of the box, then there's an acceleration towards the unbalanced force. You can also see this if you're on something like a curved path. So if this box is sliding off a cylinder, all right, the normal force is always perpendicular to the surface. So right here, I know this is curved, but if you looked at it, if you zoomed in, this would be more of a eventually it sort of looks like a straight line, and the normal force is pushing perpendicularly away from that. Okay, so that's the important part. We're talking about perpendicular. Of course, perpendicular lines are going to come into here, and perpendicular lines have opposite reciprocal slope. So, for example, this L1 line, let's make it blue, has some rise 1, 2, 3, 4, 5, and some run 1, 2, 3, 4, 5, 6, 7, 8, right? So the slope of L1 is going to be 5/8, right? And so therefore the slope of L2, this guy, L2, is going to be the opposite reciprocal. Oh, let's go slope of L2. If this is L2, this drops 8, down 8, and over 5, right? So the slope is -8/5. It's the opposite reciprocal. Opposite means one's positive, one's negative. Reciprocal means they're flipped over. Sweet. We can check it by my fancy square, labeled square, and they're perpendicular. Cool? So that's the reciprocal. More like refliprical. Okay, so take that idea and combine it with the idea of a normal force. If you're talking about this surface, and you know the equation of this surface, let's tilt this whole thing a little bit. I guess I can't tilt it. If you know this surface, the equation for it, y equals mx plus c, if you know the slope, you can figure out the slope of this perpendicular. It'll be the opposite reciprocal to this. So let's try that out. That's all this says. It says the slope of the normal force is the opposite reciprocal of the slope of the tangent. And this is the slope of the tangent, right? It's the derivative. That's what we've been working with the whole time. Okay, so this isn't in your formula booklet. It's just an understanding that hopefully you'll have at the end of this. And all this says is, here's my curve, right? Here's the tangent, right? And the equation for this is the derivative of f of a, and so the equation for this guy should be f of a. Right? The derivative gives you the equation for the tangent, and therefore the normal force, geez, draw straight G. The equation for the normal force, whatever the slope of that will be the opposite reciprocal of this. So 1 over that and the opposite sign. Okay, so for example, if you have x squared, so if this is x squared, the black line, right, then the derivative will be the slope of this, right? The derivative of x squared is 2x. That means that this is the slope. Oh, back this up a little bit. This is the slope, the 2x piece, And wherever it meets, right, whatever our point in question is, we evaluate the derivative at that point. So we'd say, hey, what about x is 2? And they'd have to tell you that, right? They'd say, find the normal at x is 2, and you'd say, well, okay, so the derivative of 2 is 4, right, because you plug the 2 in there. The derivative at 2 is 4. So therefore, the opposite reciprocal slope at that point is negative 1 over this was 4, so negative 1/4. We'll try that out in a second. The other thing you can do is write the equation for it. So this is point-slope form. You could use slope-intercept form as well. Depends on what syncs with you better. But this is y minus your y-coordinate equals slope times x minus your x-coordinate. It's the same thing as slope-intercept. It's just rearranged a little bit. If you did this, you could sort of think of it like this. Keep your y. Instead of y1, let's call it b. And they wrote this, but I might write it like this. Actually, I guess I'll have to write it in. This, we could call it b, or you could call this f of a, right? This is the slope of the normal. Here's x, and here's the point a, right? So this is another way. This is a way to write the line equation for this normal. Cool. At point A. All right. 3 examples. Let's try them out. Get your head out of the way, G. And we'll go from there. So find the equation normal to this at this point. Fine. Okay. A couple of things we can do first is, I know that this point is, the x is 4, but if you plug the x into here, we can find the y value there as well. And so you plug 4 into here, root 4 is 2, so 8 over 4 is 2. 8 over 2 is 4. There we go. So that's where this 4 comes from. Ching, we just plugged in x. All right. We want to find the normal, so we have to find the tangent's slope. So we can take this and turn it into a power instead of a fraction. So this negative 1/2, this and this are fundamentally the same, and then we run our derivative. So you multiply negative 1/2 by 8, you get negative 4, and then you decrease this by 1. So negative 1/2 you decrease by 1, negative 3/2. Hopefully that's not too crazy for you at this point. So this is our slope, but we want to find that slope at this point, at this x point. So you can plug in for this value into that x, and that's what this is, right? I hope that you can get this piece without using your calculator. Get from here to here without using your calculator. Think about this. If we, let's see, can we scroll down? Yeah. If we can take 4, think about like negative 4 times this, you could think about as 4, the square root of 4 cubed. The root is the 2 in the denominator. The 3 is the cubed, and then take all of that to the negative 1. So actually, let's do it this way. 1 over that. So this is 2, right? So this is really negative 4 times 1 over 2 cubed, which is really negative 4 times 1 over 8, which is really negative 4 over 8, which is really negative 1/2. Cool. Now, you don't have to write that out, but hopefully you can do that in your head. It'll save you a lot of time. All right. So we know that this is the slope at this point, so then therefore we're going to take the opposite reciprocal. So it's normal. This guy has the opposite reciprocal slope, so positive 2 over 1. And now we can throw it into whatever your favorite linear equation is. They use something weird. Yeah. I would probably just run it as y equals 2x minus 4. If you plug that in and solve for, M, you can use x and y, plug them in and solve for c, right? That's not too bad. And that looks about right. Here's the slope. positive, or here's the line here. This is positive slope, so up, rise 2, run 1, and intercept somewhere negative. So that looks good. Cool. Here's another trick that you can use. You can find maxima and minima, and we'll get to that a little more in depth. But it says find any horizontal tangents. And a horizontal tangent is a maximum or minimum. It's where the slope goes from being positive to being negative at some point. When it's 0, it's at that maximum or minimum. Happens there, happens there. You can do it with your calculator, but it's the same idea. You say, here's my equation, here's this piece, models this cubic, right? And so we know that the derivatives are the slope there, and so let's find the derivative. You'd say this cube, decrease the exponent, and then take the derivative of the second piece. So there's the slope of the tangents. So we can say, hey, well, I want that to be 0. So if we set this equal to 0, it's just saying when is the green line not positive, not close to 0, but 0. When is it 0? And if you solve that, you can solve it by factoring, and you get 2 solutions, one at -2 and one at 2, which makes sense, right? Because it happens twice. And so now you can just take that piece, plug it back into the equation, and that's all we're doing here. You're saying, hey, oh, what about 2? Oh, we're plugging 2 back into the original equation. You get 2 cubed is 8 minus 2 times 12, 24 plus 2, you get 14. So that happens here. And you do the same thing, plug it back into the original equation, and you get 2 spots where this occurs. Neat. Cool, you can do it on a calculator as well, but you don't need to. All right, last trick. Sometimes they'll ask you to pick a point and say, oh, okay, take this point and draw me a line and hit only once on this curve, right? Find a tangent, basically, using this point that's not on the curve at all. And say, all right, well, let's take our equation, and I know that wherever it hits here, it's going to have an x and a y coordinate. The x is good, let's just call it a. We're calling it not x because it's just easier to keep straight. So let's call it a, and so therefore the y will be a squared. All right, fine. Let's take the derivative. So f prime of x is 2x. So that's the slope of this line. And I know that whatever point that'll hit at that point is 2a, right? You're just plugging in a. So what's the slope? At a, it's 2a. Okay. We can take this equation then, right, and find the equation for the line. It's going to be in terms of a, right? And so this is really this. It's just that this piece is divided under here. Right, it's like that. So if that freaks you out, you could think about it like that, right? And in this case, b is the y value, it's a squared, and a is just a. So we can plug in what we know, right? We know that the a squared is the y value of the b, and then we rearrange, and there's our equation for the tangent. All right, that's ugly, but so if we want this equation to run through 2, 3, you plug in 2 for the x and 3 for the y into here, and you can solve for a. The problem is that, hey, it's going to turn into a quadratic, and you get 2 solutions. And you should get 2 solutions. You can think about this. If you looked at this piece, one line is going to be from here to here, just kissing the parabola once and then leaving. Story of my life. And then the other one will happen over here, where it kisses the parabola once and leaves. And so therefore you can plug those in and find the actual value for the y value. You plug it into this original equation. So you plug 1 in and you get 1, 1. You plug 3 in, you square it, you get 3, 9. Well, just another quirk. All right, so let's go from there, and I'll see you in class.